Review for homework 1, part 1. 3 questions for this part. Number 1, number 3, and number 4. So let's look at number 1 first. This one, the miss rate is very high. Here I put this percentage number 70, not 70, right, 70, right. 77% of the whole class missed this question. Yeah. First, I modify our original question. In our original question, each term, I just use the variable x directly. But this one, you can see, I replace x by x squared, right? The remaining the same. Only one special place I change a little bit. Then, suddenly, 77% couldn't get a correct answer. Most of you gave me this answer, option B. That is the same answer as our, previous exercise question, right? But here the question is different. With this change, can you just do some analysis a little more, try to, bridge the gap. Here, I talk about the concept, bridge the gap. In my video, bridge the gap. So here, there is a gap, right? There is that square gap between x and x squared. Okay? So how do you bridge that gap? One more multiplication, right? So one more multiplication. That's the way we bridge the gap. Okay? So your 6 multiplication, our original question, but you need to plus that one more, you get the answer. Right? Yeah. Quite some students, so they gave me this many, because they told me the answer is 12, something like that, right? Yeah. In that way, you didn't use the best method. You didn't take advantage of the structure, right? If you do nothing, by the Horner's rule, you just apply the, Horner's rule directly, right? Without any special treatment. So you will get that answer. But here, we need to explore, or we need to take advantage of the structure. We have a special structure here. Structure. That square structure. You need to take advantage of that. Then you can reduce the number of multiplication by 5 from 12 to 7. That's big. That is big. Yeah. So for the question like this, so I can tell you my intention. I don't want to repeat the same question another time, right? Yeah. You did that before, so why I give you the same question? Sometimes I did that, but not very often. Yeah. Only very small percentage time, 5%. Yeah. I did that. But in general, I don't want to repeat the same question. So here, when I want to give you a similar question, I modify some important part, like the one here, because I want to, check you if you can really apply the method we learned before, but you need to really digest that method and make the necessary change. Here, you need to do the necessary change. Okay? And in another thing I like to, make you do creativity, right? Creativity. Yeah. Because in the real world, you do not have a lot of chance to get the problems that you have done before. So you have to solve relatively new questions. So you have to use some creativity to solve the problems. Yeah. So here I want to give you practice on that direction. All right. So I say too much about this question. All right. So the next question. This question, I skip it. Yeah. Later in my grading, halfway in my grading, I noticed some problem. So one student pointed it out. There is no correct option to be selected for this question. So I check it again. Yeah, I agree with that. So that's why I skip it. Yeah. For the students, I took 4 points off, then I gave them back to you. Yeah. So here, why I skip it? Yeah. Because if we just apply the formula, yeah, so you know the formula, yeah. Here, in order to calculate this expression, we try to simplify it, okay, yeah. But here, we use the ceiling function. When we use the ceiling function, we need to write it using the floor function, the other side, but we should have 2s minus 1 minus 1, another one, so minus 2. Right? Yeah, minus 2. All right. And a plus 1, right? And a plus 1. Yeah. All right, so now, after that, we know here 2 times s minus 1, right? 2 times s minus 1. Okay, all right. So 2 log base 2 of 2, that's 1. 1 plus s minus 1, right? Okay. Plus 1. That one we can take it out. So we will get log base 2 s minus 1 plus 2. Okay? Yeah. All right. But if we want to write it, here, we need to going back to another version. Log base 2, s minus 1 plus 1. So that's s, right? Yeah, that's s. But we still have plus 1, right? Now, this expression, can you find it anywhere in the given options? You cannot, right? Yeah. For that reason, when I designed this question, I may got something wrong. Yeah, it happens. Yeah, but I didn't find it before. Yeah, so for that reason, yeah, so we have to, skip it. Yeah. But I need to fix this question. So the next time I can use it in a correct way. So the next time I need to give the option, this one plus 1. How about that? Yeah, something like that. Yeah. So then you can do it. Yeah. Other students, they can do it. Yeah. All right. Next question, number 4. This one, 37% of you missed this question. Yeah. All right. Here, n is given in this way. Now you need to use this special number as n. Then you simplify 2 expressions, expression A, expression B. Yeah. So let me show you. Expression A, that's easy. Okay? Yeah, because log base 10 to some special number, right? Yeah, the whole thing we treat as one number. Yeah, same base, log base, then this exponent, base, yeah, equals 10 to the 10th. Yeah, this step, I feel most of you can get it, but the hard part is when we work on expression B, then many of you couldn't get the right expression. So here, let me show you the detail for the right expression. All right, and so we plug in. So this n we know 10 to the 10 to the 10th. Okay, yeah, this whole big number to the 0.0000 another 0, 1. Okay, all right. This is just a special number, right? Yeah. This is the internal exponent number based on the property of exponential function, the same base, but exponent number 10 to the 10th, the whole thing multiply that 0 point, those things. Can we write it as 10 to the negative 6th, that power? 10 to the negative 6th. Okay, all right. So then let's work on the exponent part first. 10 base, the same, but here 10 minus 6, right? 10 minus 6. That's 4. Okay, all right. Then it should be 10 to the 10 to the 4th. Right? You know the 10 to the 4th, this number, right? So if you write it another time, 10 to the 10,000, right? Is it 10 to the 10,000? 10 to the 4th? You compare 10 to the 10,000 with 10 to the 10th, which one is larger? Okay, which one is larger? That's easy, right? Yeah. But you have to do this expression in the right way. But I noticed for many of you, you couldn't get this one. Yeah. So answer B. All right, so we finish this 8.3.